Okay, this is the continuation of the same problem. So, so if you pick 5 containers, we know that each container contain either more than 510 pounds or less than that. So that the probability that it contains more than 510 pounds, this is the answer for part A. Probability more than 510 pounds. So it's like the probability is this, or otherwise 1 minus that. So it's like the binomial setup now. Each one goes like that. P, the success or the failure, if I label it like that. So this is the P and this is the Q. So I'm going to pick 5 containers at random, n equal 5. So out of those 5 containers, so if you say that Y is the number of containers with more than 510 pounds, so then the Y has a binomial distribution with n equal 5, and the p-value, the probability of success, is equal to 0.0228. So the probability that y equal y, the binomial distribution, the 5cy, the combination formula, the p to the power y, the q to the power 5 minus y, the possible y values starting from 0, 1, 2, 3, 4, 5. So this is a binomial distribution now. So we are going to use this to answer those questions. So the first part in here, at least one container contain more than 510 pounds. So in terms of y, you need y more than or equal to at least 1. All right. So either y equal 1 plus y equal 2, the probability y equal 2, and so on. So you are using the binomial distribution. So you need to add all these values using this formula, binomial formula. So in other words, you need to add all of them together, okay? So with 1, 2, 3, 4, 5. So 5. So that's a long way to do that question. So the easy way to do that question, so this is missing out of that. So 1 minus the y equals 0, the probability that y equals 0 should give you the answer. So that's what I'm going to do, okay? 1 minus 5z 0. So in this formula, you are putting 0 here, 0 here, 0 over there. So that is that. 0 here, up there, and so on. So this part is 1, this part is 1. 1 minus that number to the power 5 is that. So that's the other way. If you do that, you already saw that 1 minus that into the power 5. But this is a more formal way to do that, okay? So the second part of that, exactly one container contains more than 510 pounds. In other words, the probability y equal 1. So that formula 5c1, that p to the power 1, q to the power 5 minus 1, which is 4. So this is the C formula, combination formula. So evaluate that. Basically, this part is 5 actually, okay? So, but you can use the formula, combination formula if you want. So that answer is going to be that. So then part F is find the 90th percentile of these x values, okay? 90th percentile. When you say 90th percentile, this is the x random variable, the probability distribution. You want to find the value A right here somewhere. So 90% values are below that, only 10% above that. So in other words, I need to find a value such that in terms of the probability x less than A is going to be 90%, 0.9. So here, if you want, you can put a equal sign or not. Has nothing to do with that because this is a continuous random variable. So now what you do next, you convert this into z, and so this the minus mu divided by sigma, this the minus mu divided by sigma. So in other words, you need to convert that x into the z random variable. So that's what I'm doing next. X minus the mu divided by sigma, a minus mu divided by sigma, this is 0.9. The other side. So this value, which is that, so now this will turn into z. So on the z curve, So on the z curve, if you're looking at, so here is my z curve centered around 0. You're looking at this value right there is somewhere over here because 90% has to be below, somewhere over there. So the idea is that to get this value from the z table, leaving 90% below. You know that this is symmetric around 0, so this got to be 0.5. So therefore this got to be 0.4. So in other words, so you need to find from the z table this so that this area is 0.4. So you need to read the z table as so that basically these are the values inside the z table. So you need to, inside the z table, you need to look for 0.4. But read it as close as you could. If you look at these values, they are increasing, by the way. If you go like that, you are not going to miss the closest value. So 0.4 is going to be, see here, 0.4, right there, point right there. Okay, so this is getting closer, less than 0.4, then over 0.4. So this is the closest value, which is going to be 1.2 and 8. Okay, 1.28. So that is coming from the z table. A minus 500 divided by 5 should be 1.28. So cross multiply. So the A value should be 500 plus 1.28 times 5, which is 506.4. So the 90th percentile is 506.4. So in other words, so what you that if you look at the original population, so in the original population, this one, so the 90th percentile is going to be exactly that. From that, below that value, 90% of the values are below that value. So the next part of the question, find Q3. So Q3, another word, is that the third quartile or the upper quartile, okay, things like that. Third quintile or the third quartile, or the 75th percentile. They are the same names for everything, okay? Or if you could be like, question could be like first Q1, same as QL, or the 25th percentile. So let us look at this. Find the Q3, okay? So if you want to find the 75th percentile, you want Q3 value leaving 75% below. So the X less than Q3, this is the 75th percentile, the area should be 0.75. So you convert this into Z minus mu divided by sigma, minus this thing minus divided by sigma. So this part will turn into Z, that. So the area below this value, so if you're looking at the Z table, okay, so we are looking at a value on the Z table, whatever that area below that should be 0.75. So this is symmetric around around 0, so this got to be 0.5, so this got to be 0.25, all right, because this everything has to be from here to here, 0.75. So you need to read the Z table for this value inside the Z table, okay? Inside the Z table, look for the closest value, 0.25, for 0.25. So here I'm going this way, 0.25. So when you look at 0.25, this one, see, less than 0.25, more than 0.25. Okay, so this is actually the closest value. The next closest value is that. Kind of, it's almost near in the middle, but precisely not in the middle, all right? So this one, so I would take this value, okay? So here this one, 0.67, okay? So 0.67, so that is going to be 0.67, that, so the Q3 is going to be that, so it's a 503.35, okay? So that, so when you read this Z table, unless is if it is precisely middle, you go for the average. Say for example, if I ask you to find the C value this way, see, so whatever the value, leave in 90% below, 95% below, say for example. All right, so if you want to figure out this probability, so it's going to be so here 0.95. all right, so here if you look at 0.95, so here actually 0.45 you're looking at 0.45. So it's going to be 0.45 is in between these two values, exactly in the middle. Okay, 1.64, so 1.64 and 1.65, 1.64 and 1.65. so since it was precisely in middle, you might want to take one average of these two. Okay, all right, like that. So I'll stop here. The next example.